Okay, this is basically what happens when you overflow the CAN table. And once the switch becomes a hub, all the transmission is going to work like a hub. That is, all the communication is going to be flowing out of, okay? It's going to be sending out of every port. So now it's acting like a hub. Okay? And the way to overflow the CAN table is, you use a tool, of course. But what does the tool do? Well, what the tool do is the hacker is going to be spewing out a bunch of stuff through the port that the hacker is connected to. And every time it's going to spoof a different MAC address. So now that one port says, look, I have hundreds of MAC addresses attached to this place. So I have to, make sure that I fill the CAN table with these hundreds and hundreds of MAC addresses on that port. And eventually that's going to overflow it. Okay, does that make sense? Okay. So how do you protect your switch from that? Yeah, okay. So Lisa, would you know how would you protect the switch from doing that? CAN table flush. Terry, what's that? What is a CAN table flush? Are you saying resetting the switch? Oh, right. Okay. So, but that's not going to stop it from overflowing it. I mean, it will clear it after it overflows, after a certain amount of time. Is there anything that you can do on iOS to stop this from even happening? Right. So there's a setting called port security. Port security. So does anyone know what that is? Security on the iOS. So the port security on the iOS will limit the number of MAC addresses that you can assign per port. Right, Terry. That's right, exactly. You could do that too. So you can lock a MAC to a port by just manually putting it in there, or you can say the first one comes in, takes it, or you say the first three that comes in takes it. So these are called sticky ports. Yeah. So there are several settings on the port security on the iOS that you can do that. So once you do that, Mac, the CAN table is not going to overflow, because when the hacker tries to send hundreds of MAC addresses, it's only going to take like the first three, and so it just ignores the rest. There you go. So that would be the thing to do on this. Okay. People are having some problems, right? Because now I only have, who am I missing here? I'm missing somebody. I don't know who I'm missing. I just want to check. Can everybody hear me and see the whiteboard okay? Or is there some kind of delay? Okay. All right. Okay. Okay. I just want to check. Yeah, Chris. You're okay too? Okay, sounds good. All right. So then here's another thing at data link layer. Okay. Now we're all talking about MAC addresses, right? But I do have to talk a little bit about to explain this phenomena, right? I have to talk about TCP/IP. So what happens when we're connected to the network is, you know what? I'm going to have to use. I'm scanning for place to draw, and I don't have any place to draw, so I'm going to put another. I'm going to open up another whiteboard. Okay. So one of the fundamental things about the networking is this. When you have a segment, which is, when I'm saying segment, I'm talking about the broadcast domain. Okay. And let's say you have and I am kind of jumping across to like layer 3 already, okay, but because I need to talk about layer 2 issues. Okay, and I have a router, and let's say on the other side, I have D. Okay, and everybody's going to have the, you're going to have a MAC address. It's going to be A is going to have MAC address for A, and then you have an IP address for A. It's going to have a MAC address. You have an IP address for B, right? So because you have to have the physical address and the logical address in this whole TCP/IP scheme, and you have MAC address for D, and you have an IP address for D. Okay, and on top of that, of course, you have the router, the MAC address for router, and you have MAC address for router, and you have the IP address for router, one, and then you have, whichever, so MAC router 2, and you have the IP address for router 2. Okay, so let's say everybody has these addresses. And as I mentioned, on the local segment, which is a broadcast domain, only thing you need really is the MAC address to send. But across the ocean, across the cloud, you need to have an IP address until you get to the last segment where you reach router 2. Okay. Then you actually need the MAC address for D for the router 2 to send it to D. So the question is, when, let's say you were tasked to set up computer A onto this segment, what are some configurations that you have to set up on PCA so that PCA can talk to people on the segment as well as across the internet? What are some configurations that you have to set up? I've already given you one, which is IP address. Okay, so you have the IP address, the gateway and subnet mask. That's right, right. And in addition to a DNS, there you go, very good. So you have the subnet mask, right, and then you have the default gateway, DNS, right. So the subnet mask will look something like, if this thing is like 192.168.1.5 or something, then the subnet mask would be something like 255.255.255.0, right? That's what basically what it looks like, doesn't it? And let's just for kicks say that this network is 192. It's all internal. It's a big network. 192.168. Say it's a 2 network, 2.3 or something. Okay. All right. So let's say that's the scenario, right? Say A wants to talk to B. A wants to talk to B. Okay. How does A know that B is on the same segment as itself? How does it know that? Okay, before doing that though, Terry, before it looks up the local ARP table, it needs to know that it is on the same segment. If it decides that it's on the same segment, it will look up the ARP table. They will only broadcast if it's on the same segment. So I'm asking, it's a large right one before it. Exactly, Raymond. So A is going to look at the take the subnet mask, okay, and take the B's IP address and apply the subnet mask to it and check the subnet, okay. And B is going to have something like 192.168.1.6 or something. So then the network part then is 192.168.1 based on A subnet mask. And then A will look at its subnet, the network, and say, look, no, I'm on the 192.168.1. We're on the same segment, right? So that's the first logic, exactly. And if A wants to send it to D, it's going to say, look, what is the network? 192.168.2.6. Apply the subnet mask, it's 192.168.2 network. It's a different network. It says, oh, I don't know how to send it. Send that address. So I have to send that to my default gateway because I don't know how to send it. Right? So that's the very first thing that happens. So now getting back to the initial scenario of A wanting to send something to B, right? Check the subnet mask, check the network, and say, we're on the same network. Now I look up my ARP table. I look up my ARP table. So then, let's say it's first thing in the morning, you don't have anything in your ARP table, right? In that case, Terry, you do the broadcast, right? And what you do is you do an ARP, don't you? Right? So ARP then is address resolution protocol that says, hey, and it's a broadcast to that segment saying, hey, I'm looking for the MAC address for 192.168.1.6. If you have that, please send me your MAC address. And B, looking at that and say, hey, that's me, right? And it'll send a unicast message back to A. Say, look, here's my MAC address, MAC for B, right? And at that point, A is going to fill its ARP table with the IP and MAC mapping for B, and then send that frame to B by sticking the destination MAC into the header information. That's basically what happens, right? So then what does this ARP table look like? Well, let's take a look at it. I'm going to show you the ARP table. Windows X, and prompt. I will show you the prompt right now. Hang on. Okay, you should be seeing it pretty soon. Okay, you should be seeing my prompt. And if you do ARP, they'll give you a whole bunch of stuff, so you can do ARP -A. And so you see that I have two interfaces connected from home, and everything that's static, just ignore. You have this thing called dynamic, and it's 192.168.1.1. That's my default gateway. So I have the physical address, which is the MAC address for my default gateway. That's basically what that is, right? So if I had somebody else on my segment, then I would have an entry there, and 192.168.1.6 or something, and then with the physical address, and that's basically how you would route it. Okay. So skipping back then to the whiteboard. Okay, so now I'm back on my whiteboard. Okay. So that's basically what an ARP table does, right? So it just puts in people that you want to talk to and the mapping of the MAC address and IP address, right? And let's say that now I'm talking to D. I want to talk to D. Okay, first thing in the morning, I check it. It's a different network. Okay, so I said, look, I don't know how to send this thing, so I'm going to send it out to my default gateway, which is my router that is connected to my segment. Okay, that's where you have the MAC address of R1 and IP address of R1, right? But I don't know how to send it. So what do I do next? What does A do to send this frame to the router? What does it have to do? That's right. So how does it send it, Terry? We're still talking data link layer, so I need to know if you understand. How do you send it to the default gateway? Because I don't have an address for it. The only thing I have is an IP address. Yeah, Terry, I know you know this. Right? So basically, you say, look, ARP, okay, I need to send this default gateway. The default gateway address is, IP address for R1. I'm looking for MAC address for IP address of R1. It's a broadcast. Yeah, exactly, Terry. No, not yet. So it has to send to the gateway first. So I'm just talking real. I know you're going beyond it, okay? But right now, A has to send it to R1. Okay, it has nothing to do with routes. Yeah. Okay. So A will do an ARP and say, give me the MAC address for router 1. Router 1 replies, say, here's my MAC address. Put that into your ARP table, and then A will put the default gateway MAC address into the ARP table, and then forward the frame to the router 1. And then, Terry, yes, R1 is going to talk to other routers and figure out the route and send it across its way to R2. Okay, so we haven't got to layer 3 yet. So happily, the frame goes all the way to R2. Okay, now R2 knows that it owns 192.168.2 network. It said, I own it. So if you want to talk to 192.168.2.6, I can handle it. Right? But then once again, it's first thing in the morning. So what does R2 do to actually send this frame to workstation D? What does it have to do? First thing in the morning, nothing in the ARP table. What does it have to do? I'll wait 3 seconds. 1003. Okay. Raymond. Broadcast. That's right. It'll do an ARP. It'll do an ARP. It says, look, I'm looking for the MAC address for D. Here's the IP address. And then D will say, hey, that's me. So here's my MAC address. And then the MAC address gets into the R2's ARP table, and R2 is able to send that frame over to D, right? So that's basically, at the data link layer, that's what happens, okay? We haven't gotten to the routing layer yet, layer 3. So that will come on the next layer, okay? So if that's what happens, okay, let me show you how a man in the middle is done in this way. So let's say that there's a hacker. Okay, let's say there's a hacker here. And hacker wants to be man in the middle between A and router, right? So what it wants to do, what it seeks to do is this. It seeks to be in the middle of A and R1, okay? And in this case, this is what happens. Remember that in the ARP table, there's an IP address and MAC mapping, okay? So basically what happens here is the hacker is going to have a hacker's IP address. So it's going to have MAC address for the hacker, and there's going to be IP address for the hacker, okay? And A and the router both have the ARP tables, right? And they'll have the ARP table. In the ARP table, the A will have the MAC address for the IP for the router because they asked for it before. So it knows, A is going to know the MAC address for, it's going to have the IP address for R1, and it'll have the MAC address for R1. And with the router, it's going to have the IP address for A, as well as MAC address for A. I mean, that's the only way that they're going to be able to talk to each other. So these are in the ARP tables, okay? And the reason why these entries are in the ARP table is because somebody ARPed it. They say, look, ARP, tell me. And somebody sent a reply, saying, here it is, okay? Now what the hacker is going to do is something called the unsolicited ARP. Unsolicited ARP. So the unsolicited ARP is nobody's asking for the the MAC address, but he sends it anyway, okay? So the hacker, he or she, will send a reply back to A saying, look, I'm IP of router, and here's my MAC address. But instead of sending the router's MAC address, it's going to send the hacker's MAC address. And the recipient is going to replace the MAC address with the MAC address for the hacker. See, it updates the ARP table. Say, oh, I didn't ask for this, but now you're telling me that something's been updated, so I'm going to update it. So the hacker is going to do the same thing to the router. It says, look, here's the IP address for A, but I'm going to give you MAC address for H. So now the router replaces that with MAC address for H. Okay, so now do you see what's happening? Whenever A has to send to R, it's going to send it to the hacker. And whenever the router has to send back something to A, it's going to send it to the hacker. So the hacker is right in the middle. You know, he just like shuffling things from right and left. And in the meantime, he could change information. He could look at the information. He could do anything he wants. Do you see how this works? This is called this is man in the middle. So this is man in the middle. And what we did is called ARP poisoning. Okay, and the key was sending the unsolicited ARP. Unsolicited ARP. Or sometimes it's called gratuitous ARP. Gratuitous ARP. Because you're giving it, you know, even though nobody asked for it. Okay. Any questions on this? Any questions? Any comments? Okay, so this is the issue that happens at layer 2. No questions. Okay, good to go. Anybody else?